let's get started. Let's see what we got today. Hopefully you guys can hear me all right. Brightness is a little low. There we go. Now I can see this a little bit better. All right, sweet. I think we're ready. Okay, so we are trying to get into our binary search tree. Give me a second. There's something I meant to do. There it is. Get that set up. That's good. Hey, Teeny. How's it going? How are you today? It's going pretty well. The dentist did not cancel yesterday. I did have my teeth cleaning. It was fine. It was whatever. I hate the dentist. It's not my thing. I know some people just love the dentist. Not me. You're at the library doing some studying for your thesis or just chilling? All right, awesome. That looks good. Let's see here. Oh, I have my Emacs. I have my Emacs. Oh my goodness. Swalker, what's up? The Swelker. The Swalker. The Swalker. How's it going? Theldavalen, thanks for the follow. Many appreciations. For some reason, my feed of activity isn't updating. Hold on one moment. There it is. Okay, it's showing. It's showing. Hey, Prevent. How's it going? Only Rails. We're just going to do Rails today. Hey, thanks for the follow, Ordaz. Ordaz Gustavo. Teeny Turner is basically famous. Like, everybody knows. Everybody knows Teeny Turner. Rickety Rocket, thanks for the follow. And hi Kitter. I don't know how you say that one. You can tell me if you want. Hike. Or just hi. Is this stream Lee Gandhi? Rickety Rocket. Yeah, no, that's fair. That is totally fair. Wait, what? Why do you think I'm on a Mac? I don't understand. I mean, Swalker's using a Mac, so there's that. Kolkis. Thanks, Kolkis. Thanks for the pronunciation guide. Thanks for the follow. Yeah, Swalker uses a Mac. Okay, I do too. This is a Mac. I complain about it a lot. So if you're gonna hang out here, you're gonna know I complain about my MacBook a lot. And that's also because it's an Intel-based MacBook. And we all know why I have an Intel-based MacBook. And that is because work pays. Or as I like to say, hashtag work pays. So it's totally fair to not enjoy the Mac. I might enjoy it more if it was you know, like one of the new silicone things, but nope, not in the cards. not in the cards for me at this point. And oh yeah, we're definitely using Emacs. There we go, Teeny, thanks. Yeah, the Emacs is part of this. I mean, I am a little bit on the fence. Like, I do not like Mac OS. Let me put it that way. I don't like Mac OS very much. I don't like some of their hardware decisions. But given the choice right now between like a brand new latest, I don't know, what are they on, M3s now? Is that what they just announced, or is it still M2 the best you can get right now? I don't even follow this kind of stuff very much. Like if Work's paying and they're like, hey, you can have this or you can have this, you know, Linux box. To be honest, I don't know for sure what I would choose. I don't know for sure. M2 Super Mario Pro Max. Oh yeah, no, Apple's a piece of shit. Don't get me wrong. Like they're an absolute like terrible company that just tries to keep like all of the, like just an absolute walled garden, right? I mean, there's pros and cons to a walled garden, but like the way they manage their walled garden is not like above board by any means. You come in with a I8 Mac, and then you have an M1 MacBook Air and an iPhone. That's hilarious. I have my headphones backwards. The cable's bugging the shit out of me because it's on the wrong side of my head. You use your desktop workstation. No, you're good. I understand. Oh, thanks, Walker. Thank you for the subscription. I really appreciate that. Now you can enjoy the beauty of my emotes. I you know, I'm happy with them. They could be better. I'm happy. There's a few more things I want to do. Yeah. I mean, so before I was on Mac, I was on Ubuntu, to be honest, TBH. And I actually really liked it just as a daily driver. Didn't have to do anything. It was great. And when I switched to Mac, like, it was a degradation of a user experience for sure. From Ubuntu, let's see, I was probably on 11, I want to say would have been right. It was either 11 or I might have gone to the next. Maybe I got to 12. I can't remember. I know they do the whole like LTS version and then non-LTS, right? But yeah, that's how it goes. All right, I've been using a stand-up mic that you can actually see in the corner back there. Mic stand, like you would put on like a freaking stage. And I finally got a proper mic stand, which means we can do special things now. Like I can press a button and I can just stand up. I mean, this is America, right? I mean, not where you guys are necessarily, but pretty impressive. Okay. And then we can go all the way down and hold on a second. I'll have to take wait, that's all the way up. Oh yeah, that's actually pretty nice. I forgot I did this. USA. It's hilarious. Oh yeah, this is my further up. That's actually pretty good. All right, we're gonna go all the way down. Let's see. Oh, I never set that one. Oh well, 1 second. Now, there's an important part to this that you have to see, and that's that this exercise ball. You know, I've had this pre-prime before Prime ever started streaming. No, I'm just kidding. But, you know, before I ever watched Prime. So we've got 3 levels now. We have exercise ball. No, I've been sitting the whole time in my chair that I just pushed out of the way. That's what I usually am in. Yeah, I've got exercise ball. I've got ridiculous chair. Let's see. Let's give the chair a shout out for supporting me. It's a Haworth. I can't remember what they call it. Zodi, something like that. Ridiculously expensive chair. I bought it refurbed for like less than half the price. It was pretty good. It's a Haworth Zodi task chair. It's like, I believe the normal price. Let's see. Let's look it up. I don't want to just like talk out of my ass like I usually do. All right, Haworth Zodi. There it is. Okay, so if you want to buy this like brand new from Zodi, you can see those prices. Or you can get this refurbished version for $300, which is what I did. And you might think, yeah, that's right. That's right. Teeny got that. Teeny got what I was talking about. You might think that this would be like knockoff. Absolutely genuine. I was very surprised. I just went for it anyway. So, yeah, not bad. Not bad. It's a pretty good chair. I've had it for like probably 9 years at this point. It's held up. That's my Haworth Zodi. Apparently they have a new version. That's not surprising. I mean, it was 10 years ago when I bought that. It looks exactly, not quite the same. It doesn't have the little, where's the lumbar support? You guys can't see that because it's over there. But there, you still can't see it. Mine has like a nice little lumbar support. All right, dude. Hey, thanks for the raid again. Have a good day. And the sub. I appreciate it. Alacritty docs. Okay. So we've been doing this tour of terminals. $1,500 for the Zodi 2. I know. It's so crazy when you get into these ergo chairs. They're so expensive. And like they definitely help. Like, don't get me wrong. It's an amazing chair. Like even the one I got for, you know, 300 plus tax or whatever. But like that's insane. I still can't imagine, regardless of your income, it's hard to imagine putting $1,500 down on a chair. It's hard to imagine that. But yeah. There's a chair I really liked, but I can't remember. It's not the Arrow. Arrow's like very popular, like AERO. Literally what you spent on your car. Yeah. No, totally. I'm definitely not saying... I think if I wasn't able to find this refurb, I would have definitely ended up spending over $800 on a chair. It would have happened. But I just happened to find this and I really liked it. So if you're in the US, try out Madison Seating. All right, so I've been trying. It's too bad Swalker left because I know he uses Alacritty, and let's see. Can we just get this where you don't have the stupid sidebar? GitHub. There we go. That still doesn't really help that much. There we go. That's mostly you can see everything. So I tried using this Vi mode on Alacritty. It was basically worthless. Like I couldn't even paste after I yanked something. set-o-vi. I don't know what you mean. Does anybody use Alacritty in chat that like really likes it and understands how it works? Because you know, I know their whole thing is just config it like in a file. Oh, with most Unix-based shells. Okay, I see what you're saying. All right, yeah. So you do Control-Shift-I, which I just did. You see that little thing up there, and yeah, I can press Control-B. I can press Control-F. I can go up with K. I can't give it a numeric argument. You switch from Alacritty to WesTerm. I've heard good things about WesTerm. Maybe I should try that next. I tried to install Kitty and it just like didn't work on my system, and I was too annoyed to even figure it out. So yeah, look at that. Look at that nice beer emoji from Brew. Just amazing. Brew is just like one of the best. That's a joke. Okay, I couldn't even finish the joke. All right. Anyway, yeah. So I mean, sure, that's cool. I can press V, like go into visual mode, and I can select something. But let's say I do this and I go Y, right? That's yank. You would expect if I went down here, let's see, if we go here and I pressed P, it would paste it. I can't even command V while in Vim mode. All I can do is actually exit Vi mode, in Alacritty, and then I can do a command V. What's up with that? Why not use tmux? I've been thinking about it. I just never bothered learning it, but I have been thinking about it. That I probably just need to learn tmux. Yeah, so no matter what mode I press, and their documentation didn't tell me any different, like I cannot paste while I'm still in V mode, Vi mode. Yeah, no, I think it is definitely something I should do. I did look at ZellyJ the other day. It's kind of like, but it's usually not my kind of thing. Like to me, ZellyJ is like if you like something that's already okay, that's what you're saying. Yeah, exactly. So it probably wouldn't be that big of a jump for me to just learn tmux. One of my favorite engineers I've worked with, it was my previous manager who left the company a while ago, but he was the only person on our entire, like, I don't know, it's not a big company, 12, 15 person dev team that used Vim and tmux. And he was freaking awesome at it. It was pretty interesting. It was me using Emacs, him using Vim, and everyone else used either Visual Studio, the thing, or I don't have a beeper, or they used a couple of them used Cursive, which is a Clojure IDE. Because we do Clojure at work. Yeah. That's funny. That's funny, Rickety Rocket. Yeah, I'm sure I could probably do it. Yeah. I could probably do it. It probably wouldn't be that hard, but it's probably what I need to do, because Alacritty also, basically Alacritty is like, yeah, you need a terminal multiplexer. Like it would be hard to use Alacritty except for something really basic, right? Without either something like ZellyJ or tmux, a terminal multiplexer. because they don't give you anything. They don't give you splits. They don't give you tabs. I mean, you can do windows, right? Like I can do a new window. You guys can't see it because I'm only sharing that window. But, you know, that's all that you can do in Alacritty, which is fine. I don't know. I haven't been wowed about it. Let me open up a tab for WES terms so that I remember that that's on my list to try next. Oh yeah, okay. Uh-huh. Uh-huh. I know I've seen several people use WES terms, so I'll look at it. I just want to try a bunch of them. I tried Warp for a while, which is Mac only and requires sign up, and it was kind of disgusting, to be honest with you. What finally killed it for me though, like besides all the normal like grossness of requiring your email to download the software because it's whatever, and then also like you have an identity in your terminal because you have AI built in and they have to have a way to rate limit you. So all that stuff's already kind of like sus, but then there was a stream where my battery was having issues, classic, and the main power user was Warp, and I wasn't even running any processes. It wasn't like, oh, I'm running processes in Warp and that's why it's taking so much power and memory. It was just Warp, and I was like, okay, we're done with this. So I uninstalled it like on stream. it was pretty gross. All right, I'm gonna switch off the exercise ball. Back to my chair. Yeah, it like just came out last month. It was bleeding edge. Early access, closed beta. Invite only. Yeah, it was pretty funny. I don't know. I just wanted to try it out more, like, because I thought it was kind of a meme. And it was. I mean, the only thing that Warp had that was, like, I could see where they were going with it. First of all, it's like a VC-backed terminal company. Like, I don't know. I think they're VC-backed. I could be wrong. But, like, it's an actual startup trying to make money off of a terminal. That's kind of weird already. But basically their whole thing was like this Teams feature, and they wanted to basically sell SaaS, like terminal as SaaS. Yeah. And it was in order to like have all these playbooks and scripts that you shared across your team and could easily run, like, you know, on any machine on your whole team. Yeah. It's like I kind of got what they were going for like, you know, a TypeScript dev team. sorry Rickety Rockety. It was just so easy. Yeah, but it's also just kind of gross. It's like, okay, let's pay Warp $5 per seat to have shared scripts. It's like, why don't you just have a scripts dir in your repo that and then you have to teach your people how to run a shell script and not just click on a UI. But, you know, I mean, can they handle that? I'm not sure. Okay, enough of my takes, I think. But yeah, pretty funny. Okay, this was just my Emacs config up. There's some eLisp action for everybody. I know that's what you're here for. Let's see. I don't need iBuffer open. Yep. Nice. Okay, so where are we? We've been working on a binary search tree in Rust. we've done quite a few data structures already for those who are new. I think we actually do have some new people from the raid, so I'll just go over what we've done so far real quick. We've done an array list. We've done a doubly linked list, singly linked list, a queue, a ring buffer, and a stack. Various technologies underneath. I say technologies, but I just mean different parts of Rust. You know, our stack is using unsafe, direct memory access, blah, blah, blah. Ring buffer is actually doing that too. Has some interesting parts. Our queue is just on top of our doubly linked list. Our linked list is using a lot of boxes. Our doubly linked list uses RC ref cell. And our array list was the first one we started with. It's just a vec underneath. It's mostly just like a play data structure. But, you know, I say that, and I was talking to Brooke Zucker the other day, who's another Rust streamer. And he was talking about when he taught people, and of course, if you're using JavaScript and you're implementing data structures, it's like you're just going to use a JavaScript array underneath. And at the end of the day, what is a JavaScript array? Well, it's just an array list. So, you know, and what's a vec? A vec is just an array list as well. And here's a little explanation of what an array list is, kind of, and an example of a TypeScript interface for an array list. But yeah, anyway, his point was it is still actually helpful and cool and powerful to understand that you can wrap a data structure in basically any language, even one that does already what you want it to do, basically. No, but you can put a custom interface on top of that, and that can be helpful for people to understand and useful depending on your use case, right? So I get it. I thought that was kind of a good take, you know, because sometimes you know, I'm just like, yeah, this is a fake array. But yeah, that's partly why I decided to do this, Colchis. I've been in the industry for 10 years. Did TypeScript, JavaScript, and Java full stack for the first 5-ish. And then the last 5, been doing Clojure, backend only. Thank the Lord. Works so much better with my brain. Yeah, and you know, I've learned a bunch of other languages on the side, but that's what I've been mostly doing. What was I gonna say? Yeah, I mean, and at least for what I've done, a lot of SaaS, a lot of web services. It's like, knowing basics about data structures is very helpful for choosing what data structure to use. Did I ever have to implement my own data structure? Not a whole lot. Not a whole lot. Nice. Good deal. Wait, do we have someone in chat that's actually older than me? That would be amazing. I'm basically like a boomer at this point. Like in I feel, at least on Twitch. On Tech Twitch, I'm basically a boomer. I'm 38. Yeah, okay. Nice. That's awesome. I'm 13. No, that's Dylan. That's Dylan Mulroy. He's 13. Yeah, I definitely get it. I don't imagine that I'm gonna feel much different when I'm 49 than I do right now. No, it's great with a question mark. It's like, do I know what being a millionaire means at this age? That's funny. It's all right, Prevan. Your teen years are time to fuck up. Is there a meme? I don't know. It's very possible. You're 12 and what is this? Yeah, is that a meme, Colchis? Yeah, I figured you were not 13, Prevan. An old one, yeah. Okay. I have been like almost completely off social media for 4 years, so I don't get a lot of things. But let's be fair. I don't get a lot of things regardless of my social media status. I recently started up my Twitter again just from a streaming perspective. I did have one tweet today. It's just for shit posting for the most part. But if people are on Twitter and you wanna be there, then sure, do it. So let's see. Oh yeah, I was gonna post that I'm streaming. Continuing our what is this called again? Binary search tree in Rust. Oh shit, I'm such a boomer. See, that was a boomer move. Damn it, I just sent that instead of, I was trying to do, I pressed Apple enter instead of shift enter. Damn it. Delete. Okay. Let's try this again. Continuing a binary search tree in Rust. Shift. I did it that time. I know how to hit the shift key. Twitch.tv/MetaMePost. Okay. Good times. I think I did it right. Yay, I know how to tweet. Yeah, I know. That's what happens when you're not like in it all the time. You start, thanks PM Walls for the like. I don't know if you're in chat right now, but still thanks. Yeah, this is.
Hey, Dad.
Hey, what's up?
Do you have iPhone charger? Oh wait, do I have it?
I think I have the iPhone charger. It should be. Where is it?
I might have it.
You might still have it. iPhone charger in this house. We have it for guests. Yep. Yeah, I was happy with this one because it's ridiculous and absurd. Anyway, I posted to Twitter. We did that, and oh, there it is. See, I forgot to scroll up. Are we reflecting on tweets? We're not supposed to be, but I've gotten distracted since Walker raided me. Which, but to be fair, was at the beginning of the stream. But hey, Allison, how are you? She's right here. She liked something of mine. Isn't that sweet of her? Let's see. So this was our array list that we were talking about, but oh yeah, let me follow you back there, Colchis, and see your amazing content. I just know it's gonna change my life. All right. Even though it's probably blank. All right. So I guess we should continue our binary. Wow, how about that cadence? Binary search tree, English. Yeah, cool. So this is what we have so far for our binary search tree. Basic structure, yay. Let's get to our actual MPL for binary search tree, which shows our public API here. We're in the middle of delete still. It's the hardest part for sure. Yeah, well, if we were gonna do like, let me think. Yeah, if we were gonna do rebalancing or rotations, then that would be the hardest part. But without those, delete is definitely the hardest part, in my opinion. So part of what I've been doing is trying to implement this all in impl blocks, like on the actual types, and it has made the code far more ugly than if I didn't do that. I just wanted to try it to see if I could make it work. I actually have no idea if it's more idiomatic to do that versus just having like private functions in this module that I use. But an example of where it's like really ugly, I will show you, would be this this delete example right here. So basically, because I need to update the parent, I am doing all of this work inside of a method on the parent. And that's because once we like delete something, we have to, you know, like replace it with whatever's underneath, and do some other things. Sometimes take a value from the bottom of the tree, right, and swap it out with what we just deleted. So that's partly this. If I just made this, there is recursion in this function, but if I just made this a function outside of here, I could just take a different type, in this case an option box node t, and it would have been a lot nicer. Here a self this is in the node impl block, so it's just a node type. And a node type for a binary search tree is what's actually holding your value, and then holding information or pointers basically to the left and right branches underneath. I can show you this real quick, assuming these are still working. There's a basic idea of like what a binary search tree might look like, in case you're not familiar. I know it's half cut off. Yeah. So basically everything on the left side of everything in the left branch for any given node is going to be less than the root, and everything on the right branch is going to be greater than or equal to. Technically equals could show up on either side. I'm trying to keep it so that that doesn't happen, but I might not be able to actually control it, and I'm going to find that out eventually, if I can't control it or not. I don't know for sure. We'll find out. So yeah, that's what we're doing. Let's see. Where were we? We were on delete. Okay. So we are going to clean this up. This is just like a get it working implementation. I did think that we could try to delete something on the left side and see if this even works before we basically duplicate this logic for the right side. I don't know. I guess we could. I guess we could do that. So let's think about what our current binary search tree looks like here. So our root node is a 10. We have a 7 on the left side with a 4 and 9 left and right respectively. Maybe we should just clear out our current binary search tree, and that's a good idea. Let's do that. Whoops, I forgot I can't move Emacs. It's the one thing I don't have window imported in OBS. And that's because if I don't if I have it window imported, you guys can't see certain special LSP things that show up. So anyway, let's go back to our browser, and let's just restart. Whoops. And then, oh yeah, so this is the problem. This is why I wanted to move Emacs, because it's outside of what I can see. Let's see. Let's open a new frame, move it over there, and go to our scratch buffer. Okay, there we go. So let's create our tree that we have in our test. We have 10, really? We have 7, we have 15, we have 9, and we have 4, and we have 17. Colchis, you got third. You got third. Here's the all-important leaderboard. I haven't checked it in a while. I think I already know who's going to be first, though, without even having to check it. $34, $58, and $2,000. Okay. Cool. So far we've only implemented delete on the left-hand side. What I believe should happen is if I deleted the 7, for like what's supposed to happen is if I delete 7, 4 will replace it. Okay. And then if I delete 4, 9 would replace it. Right. And it will make more sense here. But like if we did one more, sorry, I meant to do something greater than 4, but you know, numbers, math, so hard. If I delete 7, 5 will actually replace it, and that's kind of the algorithm. Left branch, rightmost, replace whatever node you're deleting. Okay. So we have that. Let's go ahead and delete 1 and 5 so that we know what to expect. Maybe we do want to insert a 5 actually. Let's actually, you know what? Actually, I want to insert that again. Let's just do that in our test. Yeah, left branch takes precedence over right branch. The reason for that in this case is we have to, again, maintain the fact that everything on the left is going to be less than and everything on the right is going to be greater than. So the only value in this current tree where that would be true would be 5. So that's kind of how that works. So for instance, if I insert a 6, now the only time that's true is 6, right? If I deleted 7, it needs to be replaced with 6. So what it ends up being is node you're deleting, dot left, rightmost, right? That's kind of how that works. Yeah. And then if 6 had something over here, it would just pop up if we deleted 6, and that's fine. That's easy logic to do. And we should have done all of that already. So that part's nice. So yeah, let's just go ahead and insert 1, 5, and 6, and it will actually help with our test here. Let's see. Scene. Teeny's voice in my head. So we'll just insert a 1, a 5, and a 6. Okay. So that's cool. So then what we should see if we say assert, wait, no, I don't want to do that. Well, I can actually, that's fine. Because we want to say some, what do we want to delete? Let's delete the 5. No, do we want to delete the 7? Yeah, we'll try deleting the 7. We'll see if we like it. Okay. And then we say bst.delete 7. Okay. And then we'll just do a debug print. It'll be a little crazy, but that's okay. Did I not actually finish this? Cannot apply unary operator. Okay. I know this much, but why is... What did I do? Probably something really simple. Format argument must be a string literal. What are you talking about? This is an assert, not a format. Sir, this is a Wendy's. All right. Okay. Do I have some other issue in my code? Very possible. Let's take a look. Let's do a build. Make sure that everything's building. It is. Okay. And then let's just get a full output on cargo test. You might be missing a string literal to format with. Why do you think this? Oh my god, it's because I'm using assert instead of assert eq. Skill issue. I know what I'm doing. Totally. Okay, so... we're just running this one test with no capture, so we get logs. We actually had a test fail for Stack Overflow. Okay, that means our base case for our recursion didn't work. Love it. Oh no, it actually might be the debug print. I kind of forgot about that. Let's get rid of this debug print. Let's comment out our debug prints and just make sure that that's not the problem. No, okay, it's not because of the debug print. It is indeed because of code. Okay, sweet. Let's figure that out. Okay. The only part that sucks about big text for the sake of streaming is it's hard when you have a mammoth function, which I usually don't have. It was a quick Stack Overflow. I really wonder how they do that. Like, do they just have like a static analysis on that they're just like, oh, like Stack Overflow? I've had that happen a few times where it just knows really quickly that there's a Stack Overflow. But the only time that's happened, actually the last time that happened was on our doubly linked list when I was being naive and just did a debug print. And of course, like, all the nodes point to each other like infinitely. So that was fun. But it hit that Stack Overflow really quick in that scenario too. So I don't know what's up with that, but yeah, binary search trees are really cool, Colcus. I didn't actually notice that one, that comment, but yeah, they're very cool once you understand them. It's a very cool data structure. Now, if I could just like code it easily, that would be great. I mean, I could if I wasn't using Rust, to be honest, but not about easily, but I would have been done by now for sure. But that's okay. Part of the point is learning Rust and how it doesn't work to do things. the point is learning how Rust doesn't work to do things. That's pretty much what I just said. Classic. Okay. All right. I'm too warm. Got to take this off. The pressure's on. We got a Stack Overflow. All right, sweet. Right, so let's just go through and figure out where we don't actually have a base case here. So let's walk through this function. Well, actually, let's go back to delete down here. Make sure we didn't screw something up there. This looks fine. Just saying if there is a root node, delete the value, otherwise return none, because we're returning an optional for this whole thing. Okay, so let's start here. If value is less than self.value, that's fine. We're gonna match on our left branch. If left branch is none, then it's none. That's because if the value is less than our root value, then, and is not on the left hand side, and there's no left branch, I mean, then we know that it doesn't exist in our tree. Yay, efficient search. Okay. Then we say if there is a left branch, right? And value is equal to the value of that left branch, we do all this stuff. And this does have some recursion in it, so I'm gonna have to think about that. But first, I just want to make sure that there's a good base case somewhere else here. Otherwise, if sum n, if value is less than n.value, okay, yep. Otherwise, we recur down our left branch, right? If the value is less than our left branch value, so if we went back to our binary tree structure that I showed before, I don't have a nice scene to show both at one time, sorry. But here we go, I'll just do that. So right, say we were searching for 5, we'd already gone down to 7. We know that it's less than 7, so we need to keep going down left, right? Otherwise, if it's greater than 7, we're going to recur down the right side, greater than or equal to. So that's kind of what this code is saying. And this is just kind of like a base, like, okay, well, if it's none of those, then let's go down our right and recur down with this delete, which is probably not the best name in the world for it, for everything that it does. This looks fine because at some point, no matter what, it's going to hit this none issue. This should be our base case for the recursion of delete. So then I kind of think most likely the problem is going to be in our rightmost recursion, which we say like recur right here. So recur right gets a self, returns an option box self, and it says if let some node in the right branch, then if n.right.isSum self.recur right. Okay, hold on. If n.right.isSum else recur right. Yes, that should be fine. Else, this is some interesting way of doing it with a extremely long function name, but we replace it with its child. And to go back to our binary tree, all this is doing is saying, let's see, like if we replace, let's see, I'm trying to find one that actually has the right structure. Okay, here's a good example. So here on 17, let's just say that we were swapping this out somewhere else. Even on 15, you could say that you're replacing this with the right child. That's all that does, is it just swaps those values. That's what that function does. And then it returns the value of 17 in this case. So essentially, you know, like we're deleting again, right? We're deleting the value we want to swap with. I don't know. I don't see a problem with this, like off the bat. I guess we're gonna have to do some debug printing and figure out where it's recurring, which is fine. So what do we need to do that there? We need to say t partial ord and debug. Yep. Oh, right, I forgot. We have to do that. Okay. Trait bound t debug was not satisfied. I'm guessing you just mean you're not using it? Is that what that error message means? We'll find out. Is it saying like no? Oh, okay, I get it. It's because I don't have it here as well, and I'm calling something that requires t to be debug, and I did the exact same thing. Okay, right there we go. Okay, so now let's just go ahead and get some printy values going on. So we can just do our debug prints, and we're going to say in.value here. Right, can't move it. Take a ref to it is fine. And then we're also going to do it here. And we're going to say if sum in, yeah, okay, debug and dot value. Cool. I did the exact same thing. All right, so let's just start with those two and see. It should probably just blow up printing, so we'll see what happens. Okay, sick. Look at that blazingly fast rust. I'm actually still scrolling. Blazingly fast. It's so fast to getting a Stack Overflow. It's incredible. Okay, so clearly it's stuck on in.value equals 5 at line 59. So it is in recur, right? Okay. And interesting. So this means it's never, oh my God. So obvious. I don't know why I didn't see it. So recur right is a method on self, and I'm literally just saying self.recur right. What I'm supposed to be doing is recurring down self.right. Nice. All right. So Some of this is a little less ergonomic because I'm pleasing the borrow checker. Like it would be nice if I just did, I'll show you guys real quick in case you don't know Rust. In case you don't know Rust like I do. Like it would be nice because what I actually want to recur down is this n that we already have in scope. But the problem is that we already have a reference to it right here on line 58. And so we can't get a mutable reference to it. Now, the other problem, so you say, okay, well, what if we just started with a mutable reference? Wait, does that really work? I swear I just tried this and it didn't work. Okay, I know why it's working. Okay, I know why it's working here and it didn't work before. This is funny. I'm constantly having to update my mental model, like how it would, how it works. Like as in the Rust borrow checker. So the reason this works is because before I was trying to do something like this as like a non-terminal at a non-terminating place. And so like what I'm trying to say is like this is our terminal expression, right? In our function. Like it's at the end. That's all that means. It sounds cool, right? But doesn't it sound better to say it's the terminal expression? So since this is terminal or terminating, I don't know. You could say it either way. I think it means the same thing. I'm sure somebody with a CS degree is mad at me right now. Who knows? It doesn't matter. Yeah, since this is terminal, then I can do this because it's just going to use this mutable reference. No one is mad at you. Thanks, Allie. Thanks. I appreciate that. Except for the Lord. The Lord? All right. I won't do religious things that are funny. Everyone's welcome. Everyone's welcome. Exactly. That's why I like the Terminator. Yeah. This is the Terminator. It's literally Arnold Schwarzenegger written in Rust. And yeah, so since we have that mutable reference already, we can actually, the borrow checker is like, yeah, this is fine because I'm not using it anywhere further down, right? But for instance, if I was to change this into here, just as an example, and then I was to say, let's see, I need an option box self, right? So I could actually, I know that n.write is an option box self. So I could just do this, and then we're going to have a problem. And we have a problem because I'm trying to use something that we just used here after we already moved it, right? And so that's the point. So this mutable reference lives longer, and it's not happy with this because we'd be moving this out that already has a mutable reference. That's how I'd explain it anyway. Okay. Well, that is a lot nicer. All right. Where else can we use this syntax? I think we can use it up here too. Oh my god, that's hilarious. Okay, let's update some of these places because it will make me a lot happier. Oh yeah, we didn't actually fix our bug. That might be a good idea to do. n.write dot recur, right? Except this is an option, so we need an unwrap. It's safe to unwrap here because we already checked if it's a sum. And now it's going to say that this is moving n.write. Oh yeah, that makes sense. Oh, that's why it didn't do what I wanted it to before. Give me a second here. Okay. I was getting my values mixed up. Let's just undo this. And let's pretend like, let's go back here. What? This was literally, oh yeah, it's just the thing. That's fine. And then self.write. Okay, let's see if it gives me the error I want it to. Nope, it's the same effing error. Never mind. Don't worry about it. We're trying. Okay. The point is we want to do this and we want to recur right. We can't move it, so we just need an as mute. And that should compile. Yeah, sweet. So now we're just getting a mutable reference to n.write and recurring down. This should fix our bug. Let's find out if it does. Yay. Test pass. We see what we want to see. 7 is the value that we matched on, because that's what we actually want to delete. And 5 is the value that we ended up actually getting to, which is the right value. It is a little confusing, actually. Hold on a second. Why did it just go down 5 and it didn't keep going? Okay. Okay, let's see if we can get a debug print. Okay, I said I was going to clean up things, but now I see a bug. So let's get a debug print down here, since we're on this train of thought. Okay, awesome. So let's look at our tree. Okay, we'll go to this view. And at this point, using our browser for reference, if we deleted 7, remember it should replace it with the 6. Let's see if that happened. So on our left side of our root, we have 10, 4. Oh no, we screwed up somewhere. 10, 4, 1, 9? What happened? We completely mangled our tree. We lost several values. 10, 4, 1, 9. Let's see. 10, 4. 4 has a left, which is 1. Did we never add a 6? No, we did add a 6. Oh my god. We totally lost values. Okay, this is what I was concerned about. So what happened is it deleted 5 from our tree and then just replaced it just replaced that with 4. That doesn't make any sense. Okay. Oh my god, it's completely wrong. That's hilarious. Okay. Like I said, delete's hard, you know. Okay, let's look at our logic again. Let's talk through this. So we get to delete. We find out our value is 7. We say if left is sum, so this is if our 7 node dot left, which should be 4, is sum. So we're right here. Okay. That's what n.left is in this case, is that 4. Then we're going to find the rightmost. So let's debug print what the rightmost is. And I think that will help us a lot. Let's just do rightmost dot value. Rightmost. Oh yeah, we can't do rightmost dot value because we don't know if it's a sum. So let's do it here. Whoops. Just kidding. There we go. I know how Vim works, really. Oh yeah, that's not going to work because I'm going to have to say dot as ref. I'm just trying to do it so it doesn't print out something insane. That should work. No, you still want that because you want a reference to the value. Okay, that's fine. Okay, let's try this again. Let's see what the debug print gives us this time. Nothing? Why don't I see this debug print? Oh, okay. Well, that's confusing as shit. Okay. That means we're doing something wrong. That means we're doing something wrong further up if rightmost isn't sum in this case. Rightmost has to be sum. I'm going to guess that our debug... Oh yeah, that might be a problem. Let's see. Let's see. Yeah, that's the problem. The problem is that I'm saying right doesn't exist. So no wonder they're deleting it. So the way this algorithm is supposed to work... nice. Love it. Is if we don't find anything... I forgot that I did this just... I'm just screwing myself over. I did this 2 days ago. I did this just to satisfy the type checker, and I didn't put a comment that, like, I didn't finish the else branch. Nice. So, yeah. So if there's no self.right, that means we're there. Hey, Scottish Trio, how's it going? Thanks for hanging out. This should be our bug. So if there's no self.right, then what we actually want to return is self. Oh, wait, hold on a second. I need to think about this. We're working on a binary search tree. AJ Morris 87. Thanks for the follow. I appreciate it. Welcome. Yeah, you know, just doing a binary search tree in Rust like most people do. You know, this is my first day of programming, so I thought I should do a binary search tree in Rust. Just kidding. Okay. That's what most people do on their first day of programming. Yeah, it's fun if I can make sure that I understand the logic that I'm trying to actually do. Okay. So let's think about this. We know that we found our value to delete, which is 7. We're coming down and saying, let's find our swap node, and we say if n.left.isSum. We know that's good because we even got a debug print at some point. Like a recur right never happens if that doesn't happen. So we know that we go down and we get to 5 on the right. And so we know that here, okay, so on our first iteration, self is 4, right? If n.left.isSum, yeah, self is 4. Yes, absolutely. Yeah. That makes sense. Cool. And then it's saying, yeah, if self is 4, so then look for a self.right. This will be 5. And we got a debug print that it is 5, right? We could see that in our terminal. If n.right.isSum, so that's saying, so n here, again, n is 5, the node 5. We're just gonna say it by its value. So if 5.right, which should be 6, is sum, we should continue to recur right. Okay, that makes sense. And then it's just going to oh no, I think I was right. I was right, but no, that doesn't make sense. I was right here. I think it's the else branch that's wrong. Okay. Let's think about how I wrote this. The problem is I have to keep this from the parent perspective. So if n.right.is sum, in this case that's 5, pointing to 6. Yeah, sorry. n.right is 6. N is 5. Yes, we're good on that. Then we actually want to keep recurring down n. That is what I had before. That is what I had before. And it is correct. It's just that my base case is incorrect. I'm returning none. Oh, that was it. That was my problem. No, that doesn't make sense either. Because I had self.right.recur right. Okay. What if I stopped looking at this function and just wrote out what I want to do? Okay. So we have a node which equals self. We want to check if right exists. Okay. If right exists, go down right. Yes. If right does not exist, then we want to return. Yeah, return node. But the problem is that we are looking at this from one level up. And we have to look at it from one level up for a reason, right? Let's think about this. It's because I need to replace it. But I only need to look at it from one level up, and I think I'm looking at it from 2 levels up. And that's a problem. I think that might be my problem. Because we're saying if right exists, it does because we have sum in. And then we're saying, okay, if that right has a sum, then go ahead and recur right. No, I feel like that was right before though. Okay, let's go back to this. This is what we had before. Let's see if this is wrong somehow. I think I do want a none there. But this is where we just printed out 5 forever, or this is just... So this wasn't our infinite loop. This was just wrong logic. Is that right? Or is this our infinite loop? I don't remember now. What? Okay. Oh yeah, but no, then we printed out our binary tree and it was wrong, right? That was our problem. 4, 1, 5 values. No, it's working. What did I do? I don't know what I actually changed. Oh my god. Okay. I didn't commit, so I have no idea what the state was before that was wrong. I know. I guess the last run was when I was skipping over and recurring down right again. Oh, that's so weird. Okay. Well, nice. I'll take it. Let's just make sure this actually looks right all the way. So what we should see is 10. Well, you deleted 7. So what we should see is that 10 goes to 6. 6 dot left is 4. 4 just has a left of 1 and a right of 5, and there's no 6 here. And there's no reference to 6. And then the right 9 is on 7. Oh yeah, right. The right 9 is on 6. So I believe we actually have the branch. Yeah. So if we go back to our browser and we delete our 7, and that's the tree we just looked at in logs. It's not like a nice way to look at it, but that is how we look. That is the tree. So our logic actually works. How about it? Okay, well that's nice. I got pretty confused, and I think that's the part. Like, it is confusing code. There's that, and the fact that I say, you know, if in right is sum, then recur right. I mean, it does make sense expressively, but it is a little bit weird because a lot of times you're checking if it's sum so that you can then do something with the right, you know? So I don't know. It's interesting. And then we're just replacing right with left child. In this case, left child is none. For that 1 all the way down. Let's see if we can get left child to be sum and make sure that that part works. So, oh, I was just talking about code in my editor. Sorry about that. Forgot to switch over. So let's insert a 4. So 4 is going to be on the left side. And now we're going to delete our 6. And what we should see is that 4 goes to 4. And 6 is replaced with 5. So let's see if that's true. Back to code. And we're going to just replace this with 6. And replace this with 6. Cool. So we know the case above works. We don't need a debug after that. So let's just leave our debug exactly where it is and run our tests again. Okay. So we know that this is passing. Let's see if we got what we wanted. Oh, I forgot to insert a 4. That might help. dst.insert 4. Okay. Try that again. Okay, looks good. So what I expect to see is 10, left is 5, left is 4. For 4, the left is 1, the right is 4. Yep. And for right, we still have the 9. Okay, exactly what I expected to see. So if we go back to our browser real quick and delete our 6, this is the current state of our tree. So 4.right is 4, which is what we had in our test. Cool. That's pretty nice. So now let's just copy that code over to the right hand side, and delete might actually be done. There's obviously a lot of cleanup we can do, but delete might actually be done. just thinking through something in a second, for a second. Yeah, I think we can do that. Let's try it real quick. There's a little bit nicer syntax we could use here. Let's use the if let syntax and say sum left equals n dot left, and we can do a equals and mute n dot left. And if we just do that and this, we should be good. Okay. And then instead of saying n.left.as mute here, let's just make sure that I'm thinking about this right. Yeah. Instead of that, we should be able to say, that was extremely good, right? We should just be able to say left.recur right, which would be nice. Okay. That compiles. And that's a lot nicer. Rightmost dot is sum else n dot replace left with left child. Now here's another place where we could probably make this nicer, which right now rightmost is, oh, let me think. I want to return an option box node T. Is there a nicer way to say this? I mean, in some ways I just wish I could not have the let and the if and just like combine them together, but I'm not seeing that right now for some reason. So I guess I'll just leave it. So we have an if let sum left. I don't think I've ever done this before where I did else if on an if let with that. It's a little bit weird, but I think it's fine for now. Let's just make sure the tests keep passing and that our tree still looks the way we expect it to. Okay, test pass, that's not too surprising. And tree looks the same. 10, 5, 4, 1, 4. Yeah. 10, 5, 4, 1, 4. Looks good. Okay, that's awesome. Okay, cool. So I think with that done, we are actually ready to do the right-hand value. And recur down right, and then we can kind of see where they're the same. And hopefully make our code a lot nicer than it is right now. So I think what we'll do, yeah, let's just yank this whole block. It's 24 lines, and then paste. Okay. So if there's something on the right, if the value equals what's on the right, then we have that value. We then look for the swap node. It's actually the exact same logic, I think. Let me just think about this. The fact that it's on the right doesn't matter. We found the node, and we're just going to do the exact same thing. Okay. That's what I wanted to know. Good to know. So that's very interesting. So that means actually, otherwise we recur down. And I get why I'm doing it this way. But what is the difference between these two? I don't think it's anything. I don't think it's actually any difference at all. I'm just trying to think of, yeah. No, we could make this a lot nicer. I just have to think of how I want to do it. So if value is less than self.value, then I should be able to just say self.left.asMute dot, you could say delete. Oh, that's good. That's good. I like this. Okay, so what we're going to do is we're going to rename our delete function delete from, because basically you pass it a node and you're saying, I want you to delete this node from the tree that I'm passing. You know, essentially, I know it's not the tree, but it's the node that has all the branches. That makes sense to me. And then we create a new method called delete. And that is going to actually do our delete logic. And oh, that's not exactly true though, because it could still recur down. Delete from, just give me a second. Is there a difference between this? Like if I'm only calling this once, then it actually seems like I should. Oh no, I use it as a recursion. Right. Nope. That does make sense. That does make sense. It'll be interesting to see how this works. Okay, we'll try it. Delete value t. I'm not saying my naming makes sense yet, but that's okay. Who needs naming to make sense? Okay. And then let's see how long this is. It is down to 33. Okay. 33, whoops, not what I meant to do. D33J, yeah, that looks good. And we'll go here, paste above, and we'll go dirty style for easy indenting and use our mouse. Okay. And there's probably an easier way to do that in Vim, but that's okay. I'm kind of a Vim noob. This is Emacs, by the way, but it has evil mode. So, you know. Okay, so then if that's the case, I'm going to say self dot left dot delete value. Okay. Now I should just be able to say dot as mute dot delete value. Okay, cool, cool. And then there's some of this that isn't correct, such as here. This is actually delete from, and this is delete from. Okay. So there's that. And then this is saying match, and instead of matching on left, it actually should be able to match on self. Okay. Let's see how many things we just fucked up. Found expected struct binary search tree node T. Okay, okay. No field right on type and mute. Okay. What is so wrong about what I did? I'm not exactly sure. Did I just forget something obvious? I'm not seeing it. Function delete. This looks fine. I guess we should see what the compiler has to say. I thought this refactor would be nicer than it is so far. I thought it would just work. Naively. It could be self.left.asmute.delete. Method not found in, oh my god. It's gonna be okay, guys. It's gonna be okay. I'm matching, this is why I had it the other way. Now I remember. Because I needed to match on the actual option. Okay, that's fine. I can't match on a node and say none. Why didn't I see that right away? It's so effing obvious. Okay. So either we go back to where we were and we have just a match statement that's basically exactly duplicated for both left and right, or there's another nice way to do it, which there may not be because of the way that I'm trying to implement this in impl blocks instead of functions. I think it will be easier for me to think about it once I already have this abstracted out. So I'm going to try to just do an undo. Really? That's as far as your undo tree goes? What the actual fuck? Fail. Big fail on that one. It's fine. Okay. What do we have? 33? D, 33J. Yay. 8J, paste above. DD. And we'll just match whatever we have down there. Match self.left.asmute. And we'll keep this delete thing alive and still call it delete from there. And let's just run Rust formatter to do the indentation for us. and then cargo format, whatever. I say Rust formatter. I don't know. It's fine. It's fine. Okay. Then we are going to grab the interior of this match, which is 22. Okay, and this is going to be our delete body now. Okay. So then how I would expect this to work is that we can just call this as n.delete value. That seems fine there. Okay. And then everywhere we say n is actually going to be self here. This is a good time for me to figure out how block level find and replace works in BIM, because I don't actually know. I'm going to pretend that it works by going into visual mode and making a selection such as 18J, and then going into my commands and doing a replace like I usually would. No. Interesting. No, that's still full file. Huh. Alright, let's look it up. Because I need to know this anyway, and I just haven't bothered to look it up yet. And if somebody in chat knows how it works, you can let me know. Okay. How can I... Whoops, I need a new chat. Nice one. Okay. New chat. Close sidebar. Move this over. There we go. That looks good. How do I find replace in a selection in them? While that's generating, I'm going to check this. Okay. Enter visual mode to select the text you want to find and replace. Character-wise selection. Press V and then use the arrow keys. Line-wise, okay, sure. Press to enter command line mode and you'll see the cursor. That's what I tried, but it didn't work. I'm too scared to do it because of how crappy my undo is. I don't know if it's actually... Okay. All right. Let's just try this again, even though evil mode doesn't think that it's going to work. Yeah, it didn't work. Okay, it's fine. I'm just gonna do it this way. I could do it in Emacs, but it's fine. It's not that many places. Wait, what am I doing? Oh, whoops. I was hitting Shift J. I didn't mean to. I don't know why I was holding down Shift, but that's okay. I feel like this might not work. Because before I had N, swap. Oh, good. I did paste it down here. That's good. Let swap node. I don't know. Oh, that's funny. Oh my gosh. That's ridiculous. Obviously, that's not going to work. And then swap self dot value. Right. Swap self is not a thing, but things mean swap node. Oh, it's swap n. That's right. My fault. My fault. Okay. It works. I just made typos because of my Vim skill issues. That's all. Cool. Well, that's nice. Let's make sure it works. How about that? Looks like it builds. Let's try a test. Okay, tests are still passing, and we have 7, 4, 1, 5, 4, 6. Is that correct? I don't even remember anymore. Nope, it's not correct. Okay. Okay, let's see. Binary search tree. 213. Oh wow. Yeah, no, this went completely off. The root node is now 7. Okay. Alright, let's compare our code real quick. I need to go soon, but obviously I made a typo. I didn't do that very well. It was pretty terrible, to be honest with you. Okay, let's do a horizontal split. Let's go down to our code that we copied into our right branch, which I'm very glad that we did that, so we didn't lose our actual working code since I was dumb and didn't commit it. And let's see where we went wrong. Let swap node if let sum left equals and mute self dot left. Okay, and this is if let sum left equals and mute in dot left. Okay, that should be fine. Let rightmost equals left dot recur right. All this should be the same. It is else in dot replace left with left child, and this is just saying self dot replace left with left child. And I think that's also right because we are calling this as n dot delete value. Yes, so n is in fact self, as we thought. Okay, n dot replace left with left child, else if n dot right dot is sum, n dot replace right with left child, else none. Okay, that should be fine. And at no place am I actually making a reference to self anywhere here. Oh, there it is. That's why it's not working. It's this right here. Else self.left equals none. Dang it. So there was a reference to the parent node right there. That's the problem. Okay. Interesting. So this is actually the parent. That was my copy pasta mistake right there. And this is actually where the code actually diverges anyway between left and right. Which is, this should be self.right equals none. Koovy man, hey, how's it going? Thanks for the raid. How are you guys doing? Wow, look at all those paratroopers coming down. Yeah, we're writing some Rust. Hey, thanks for the follow. I appreciate it. Do I know Rust? I don't think I would say that, Allison, that I know Rust. I try to write Rust, but I don't know if I know it. I was trying to make my binary search tree code a little bit nicer, but then I realized like where the problem with that was. like where I actually needed to update something deeper in the code, and the logic branches actually diverge a little bit. Doing BST, knowing Rust, yeah, you know, yeah, sounds good, Kuva man. Thanks again. I really appreciate it. Hope your stream went well. I saw you were. I joined earlier in the day. Saw you were doing some cool stuff. Let me give you a shout out. I almost forgot. So yeah, it was nice to see some Rust game development going on. So yeah, enjoy your food. Yeah, how are you guys doing, Raiders? Welcome. I'm Metame. I've been working with Rust about 3 months. And I have, let's see, I've been in the industry professionally 10 years. I started with TypeScript and, well, actually JavaScript and Java as a full stack developer. And we eventually, went into TypeScript and stuff from there. That was 10 years ago. I stayed at that job for a while, and then about 5 years ago, I got a job writing Clojure full time, and that's what I do now. Is I write the Clojure, and I've played with a lot of different languages over the years, Haskell, other things, just like learning different ways of doing things. I always wanted to play with Rust, but just never quite it wasn't the right time to do it. And so I decided a few months ago, work is pretty chill right now. why don't I just stream some Rust and learn while I go? So yeah, we've been doing data structures in Rust, and it's been pretty fun. You can't stand programming languages. Yeah. Yeah. So yeah, I'll show you real quick what we've done so far. Let's see. Wrong place. Here we are. So we've done, we did an array list. That's where we started. And then we just implemented that, whoops, with Vec under the hood, which is an array list, right? You know, it was just getting our feet wet. And then we went into a stack, and that's where we used some unsafe, did some contiguous memory block stuff. It was pretty cool. And then we went into our linked list. We did a singly linked list using box. So that was fun. Let's see, there you go. That's the basic structure of our linked list. And then we went into a doubly linked list using RC ref cell. And we got that one working, and that was fun too. And then we did a ring buffer. Ring buffer was a lot of fun. Using unsafe, manually allocating memory, all that kind of stuff. Which was cool. So, and then we made our ring buffer pretty thick. We not huge, but you know, we implemented a nice debug print for it. We implemented index mute. We did an iterator. We did a double-ended iterator. It was pretty fun. And then we've been working on this binary tree this week, binary search tree. So yeah, that's what we've been working on. Let me know if you have any questions. It's been a lot of fun. This is what I do. We're going to go through data structures for quite a while. Maybe some algorithm stuff. I mean, you kind of are implementing algorithms when you're implementing, especially these recursive data structures like trees and all that kind of stuff. But we'll probably do some actual algorithms too that are, you know, considered separate from the data structures themselves. So if that's your kind of thing, send me a follow here on Twitch. I usually stream about 4 times a week. If you like YouTube and you want to catch up on some of the things we've done, you can watch the playlist there. If you just want to subscribe, it's there. And if you want to follow me on Twitter, I don't know. Why do you want to do that? I don't know, but it's there. So yeah, that's the things. Give me 1 second. So I had delete working, and then I didn't like the way it was done, so I started refactoring it, and that's when things started breaking, and I hit this wall again on how I want to do something. So I think I was actually just about to end when Kuvimon raided me. So I hate to do that. But we can continue the love and see who else we can raid here. But yeah, we're gonna finish this up. Probably, let's see, I don't stream on Thursdays, so probably on Friday. We should be done with our basic working binary search tree, because it's really just cleanup from here. Give me 1 second. All right, cool. So yeah, thanks again for hanging out and the raid. I guess if nobody has questions, shall we see who's around right now? I don't know. I know Kuvimon does this a lot, where he just looks at who's writing Rust, and I don't know, maybe I'm the only one. One second. Okay, sweet. So I don't know if anybody has any raid suggestions, but let's take a look, shall we? We could do Trash Puppy. We just raided her though. Actually, I haven't rated Algo Bro in a while. I mean, he's writing Java and, you know, it's like fintech stuff. But, you know, that's okay. It's not like my thing, but it's okay that people want to do that. Yeah, I'm the only one. Nice. Anybody else that... I guess it's been a while since I rated coding with Luke, but I feel like the overlap in our audiences is pretty minimal, which isn't necessarily a bad thing. Okay, let's just do Algo Bro. So sorry to not continue the Rust content as much as I would have wished, but we'll be back on Friday. I also stream Sundays, basically every day besides Thursday and Saturday. Usually stream, usually 5 days a week. If I could get my raid command working, we'd be doing really good. There we go. So yeah, thanks so much for hanging out, and we'll catch you later.